good day everyone. My name is Oluwabusayo Odukoya and you can also call me the Global Teacher. Today we'll be talking about applications of rules of divisibility in modular arithmetic. Applications of rules of divisibility in modular arithmetic. Now let's look at this question together. What is 34 modulo 5? Ideally, to solve this problem, we have to divide 34 by 5. Then we write the remainder as the answer to this question. What do I mean? So we have 34 equals to 34 divided by 5. We have 6, remainder 4. That's plus 4. That means 5 will go in 34 6 times. And we have a remainder of 4. So that means that 34 equals to 4 modulo 5. So that is how we solve the questions ideally. Now let's apply the rule of divisibility here. Now, if we want to use rules of divisibility to solve this type of question, the first question you have to ask yourself is, what modulo is this question being asked? What is the modulo required for this particular question? So it is the modulo will be the one to determine the rule to apply. So now this question is in modulo 5. So therefore we are going to use rules of divisibility for 5. And what does it state? It states that a number is divisible by 5 if it ends with 0 or 5. And let's look at this number. This number 34. 34 ends with 4. And when you divide, let's look at this number 34. And this number 34, the last digit here is 4. If you divide 4 by 5, you have 0, remainder 4. That means that 4 is not up to 5. So that means that you have 0, remainder 4. Since 4 is not up to 5. So that implies that 34 will be equals to 4 modulo 5. So you can see that we've applied the rule of divisibility to solve this type of question. Now let me repeat myself. If you are trying to solve a question in modular arithmetic using the rules of divisibility, the first question is to ask you, what modulo is the question being asked? For this particular question, the modulo here is modulo 5. That means we are going to apply the rule of divisibility for 5. What does it state? It states that a number is divisible by 5 if it ends with 0 or 5. And let's look at 34. 34 here ends with the number 4. So what we are going to do is the last digit, which is 4, divide it by 5. And that will give you 0, remainder 4. So, and that remainder is what the answer will be equals to. So we have 34 to be equals to 4 modulo 5. Now, the applications of the rules of divisibility will be very, very useful when we are dealing with larger numbers. Now, let's look at these questions together. The first question here is, what is 521,172 modulo 8? 521,172. Now, the first thing we have to ask ourselves is, what modulo is this question being asked? The question is being asked in modulo 8. So that means we are going to apply the rule of divisibility for 8. And what does it state? It states that a number is divisible by 8 if the last 3 digits form a number divisible by 8. So let's look at the last 3 digits of this number. You know, ideally, to solve this particular question, you have to divide the whole of 521,172 by 8 and get the remainder. But now, using the rule of divisibility, you don't need to do that. what you need is to follow the rule of divisibility for 8, which says that if the last 3 digits is divisible by 8, the whole number will be divisible by 8. So what we are concerned with here is the last 3 digits. So now let's see, 172, if it is divisible by 8. 8 in 17, you have 2, remainder 1. 8 in 12, you have 1, remainder 4. So that implies that 521,172 will be equals to 4 modulo 8. Now, to check if your answer is correct, you can try and divide 521,172 by 8. And you'll see that what we are going to get as your remainder will be 4. So what the rule of divisibility has done for us here is that it has helped us to simplify this particular question without going through. It has helped to simplify the way we would solve this particular question without going through the stress of dividing the whole of 521,172 by 8. So we just have to divide the last 3 digits by 8. Now let's go to the next question. 21,683 modulo 9. So this question is in modulo 9. That means we are going to apply the rule of divisibility for 9. And what does it state? It states that a number is divisible by 9 if the sum of its digits form a number divisible by 9. So let's add the digits that make up this number together. So we have 2 plus 1, 3, 3 plus 6, 9, 9 plus 8, 17, 17 plus 3, that's 20. So that will be 20. So what you now have is, the number you have to deal with is the 20, which is the sum of the digits of this number. Why do we have to add the digits that make up this number together? Because the rule of divisibility of 9 states that we should add the digits together. So when we added the digits together, we got 20. So now let's divide 20 divided by 9. We have 2, remainder 2. And that implies that the answer to this question will be equals to 2, which is the remainder we got, modulo 9. Now you will see that when you divide the whole of 21,683 by 9, you are going to get a remainder of 2. So without going through the stress of dividing the whole of this 21,683 by 9, you can just use the rule of divisibility to get what this number will be equivalent to in modulo 9. The last question, let's look at the last question. 73,445 modulo 4. 73,445 modulo 4. So let's see how we'll be able to apply this question. This question is given in modulo 4, and that means we are going to apply the rule of divisibility for 4. And what does this state? It states that a number is divisible by 4 if the last 2 digits form a number divisible by 4. So now, the numbers we are, according to the rule of divisibility of 4. Now, according to the rule of divisibility of 4, the numbers we are concerned with in this particular question is the last 2 digits. So let's divide the last, let's look at what are the last 2 digits? 45. So 4, 5, and that's 45. So now, what we just need here is to divide 45 by 4. Instead of going through the stress of dividing the whole of 73,445 by 4. So what we only need here is to divide just 45 by 4. So that's, what is 45 divided by 4? That's 11 remainder 1. And that implies that 73,445 is equals to 1 modulo 4. The trick to getting this particular question is to know the rules of divisibilities for these numbers, which we have discussed in our previous lessons. If you have any question, you can ask. Now, I want you to attempt this. What is 85,731 modulo 3? 85,731 modulo 3. Feel free to put your answers in the comment sections. Do have a wonderful week. Bye.